Kia ora koutou. Welcome to this last video on molecules. In this video we will look at two past exam questions, but we'll just take a moment to look at all of the things that we've covered during this topic so far. So much work, so much work. Well done, we've got very far. So we'll try and get through this nice and snappy. So the good news is that there's always going to be at least two questions in an exam about molecules. The first one will be about the molecule names and shapes, and the next one will be about molecule polarity. So I've taken the two questions from last year's exam and we'll go through each of those. So we'll start with the question that was about molecule names and shapes. So in this one there was a table that we had to draw the Lewis structure of each of these molecules. So I've just done that very quickly there. So this is CH4, it's a tetrahedral shape, NCl3, trigonal pyramid, and OF2, which is a bent shape. If you need any help with working out Lewis structures, then head back to the previous video where we looked through that. In this video, we're just going to be looking at how we would structure an exam answer. So the above molecules have different shapes, however, each molecule has an approximate bond angle of 109.5 degrees. Justify this statement by referring to the factors that determine the shape of each molecule. So I've drawn out a bit of a table here. So it looks like quite a lot, but with practice, you'll be able to get in the habit of just including all of this information in each answer that you give. The important parts are to state the regions of negative charge or electron density. So we'll start by doing that for each one. So a region of negative charge is either a bonding region or a region where there is a lone pair of electrons. So it could be a bonding region, could be either a single, double, or triple bond. That would count as one region of negative charge. And a lone pair of electrons also counts as one region of negative charge. And what we're interested in is the regions of negative charge around the central atom. So for CH4, we've got carbon that has 1, 2, 3, 4 regions of negative charge because it's got 4 bonding regions. This one, around the nitrogen, we've got 3 bonding regions and 1 pair of lone pair of electrons. So that still tallies up to 4 regions of negative charge. This around here, we've got 2 bonding regions and 2 lone pairs of electrons. So that's still 4 regions of negative charge. So the important thing about the regions of negative charge is that the negative charge regions are the regions that actually repel each other, because they all have that negative charge. So all of these regions of negative charge repel into a tetrahedral shape. So before we consider what the observed shape of the molecules are going to be, we need to say what the shape of the regions of negative charge will repel into. So because there's 4 regions of negative charge in each one, they all repel into this tetrahedral shape, and tetrahedral shapes all have a bond angle of 109 degrees. So that's why we'll put in the next one, 109 degrees is the bond angle of all molecules with a tetrahedral shape. Now so that's why they all, and you can say 109 or 109.5, that's why they all have this bond angle of 109.5 degrees. The number of bonding regions that each molecule has compared to the number of non-bonding regions determines the observed shape. So this is the observed shape here. So they all have a tetrahedral shape when we just look at the regions of negative charge, but the observed shape depends on the number of bonding regions compared to the number of non-bonding regions. So I'll just quickly put this here. So the number of bonding regions for the CH4, all 4 of those regions are bonding. So we've got 4 regions here. 4 of them are bonding regions. There's no non-bonding region. So a non-bonding region is just a lone pair of electrons. So the observed shape for this is a tetrahedral shape. The next one we've got, we had 3 bonding regions and 1 non-bonding region. So 3 bonding regions there, 1, 2, 3, 1 non-bonding region or 1 lone pair of electrons. So the overall or the observed shape is the trigonal pyramid. 3, 1, trigonal pyramid. And then finally for that OF2, we've got 2 bonding regions, 1, 2, and 2 non-bonding regions, 1, 2. So we'll write that in, 2, 2, and the shape will be bent. If you need any help with working out the names of the shapes, like if you don't understand the theory behind it, then just head back to the video where we look at how to work out the names of different shapes of molecules. But when you're writing an answer for an exam question, these are the important bits of information that we need to include. So we would start by saying that each molecule has 4 regions of negative charge which repel for maximum separation into a tetrahedral shape. The bond angle of these negative regions is 109 degrees. So that would be one paragraph because they're all the same for each of the 3 molecules. And then we need to differentiate between the 3 molecules. So we would say CH4 has 4 bonding regions and no non-bonding regions, so therefore its observed shape is tetrahedral. NCl3 has 3 bonding regions, 1 non-bonding region, so trigonal pyramid, and then righty. So we'll just look at the model answer for this. So bond angle is determined by the number of electron density regions around the central atom, which are arranged into a position to minimize repulsion by having maximum separation. So that's a really important part there, to say minimizes repulsion by having maximum separation. So get in the habit of including those terms. All molecules have 4 electron density regions of negative charge, which repel into a tetrahedral shape with a bond angle of approximately 109.5 degrees. So those are all of the things we've included in the table. CH4, all of the electron pairs are bonded, and so the shape of the molecule is also tetrahedral. NCl3, 3 of the electron pairs. So they're saying electron pairs there. I'm sure that if you said regions of negative charge, that would be fine as well. 1 is non-bonding, 3 are bonding, so the observed shape is trigonal pyramidal. I often just say trigonal pyramid because I think it sounds better, but perhaps you should say pyramidal. OF2, due to the presence of non-bonding pairs of electrons, so 2 non-bonding pairs, 2 bonding regions around the central atom, so it has a bent or V-shaped shape. And so that's how we would answer this question. So just including all of the information that we have on this table here. So we'll move quickly on to the next type of exam question that you'll get in exam, which is about polarity. So the polarity question from last year's exam. The following table shows the Lewis structures for the molecules CHCl3 and NH3. So we're going to go through this and work out which of these molecules, or whether they're polar or non-polar. So in the boxes above, identify the polarity of each molecule by writing either polar or non-polar, and justify your choices. So this is an important word answer as well. The first part is to be able to work out whether or not they are polar or non-polar, and then to get great grades for this question, we need to include good information in our word answer. So the first thing that we should talk about with our word answer is whether or not each of these molecules includes polar bonds. And so anytime you have a bond, a covalent bond between 2 different types of atoms, then that is going to be a polar bond. So the bond between carbon and chlorine is a polar bond, and the bond between carbon and hydrogen is a polar bond. So we'd say, yep, there is polar bonds here. The bonds are between carbon and hydrogen, and carbon and chlorine. So yeah. Here we've got nitrogen to hydrogen. That's the only type of bond we have. So yes, they both include polar bonds. The next thing we need to look at is whether or not the molecule is symmetrical. So this one is a symmetrical shape. You need to look at the previous video on polarity to understand the theory behind that. This one is a symmetrical shape, and this NH3 is not. So that's the important start of the answer that we would give there. Then we need to look at, do the dipoles cancel? So dipole is perhaps a new word that we've come across. Dipole is what we refer to when we have a polar bond. So NH, for example, nitrogen has a greater electronegativity than hydrogen. So the electrons spend more time around the nitrogen than they do the hydrogen. So this has a negative charge. What we call this is a dipole. Effectively, it's got two poles to this bond. So for non-polar molecules, what we're interested in is whether or not the dipoles cancel. So if the polar bonds are arranged symmetrically around a central atom, then they will cancel and the molecule will be non-polar overall. So with this one, do the dipoles cancel? Ordinarily, we would say yes. If this was not a hydrogen and this was actually a chlorine up there, then all of these dipoles would be the same size, and so they would cancel. But this is an exception, and in that case, it's a really good one for us to do, because even though it's a symmetrical shape, the dipoles are different sizes, so they do not cancel. So we're going to say no for that one. The dipoles do not cancel. For NH3, do the dipoles cancel? That is not a symmetrical shape, so if it's not a symmetrical shape, that's easy. They will not cancel. So if the dipoles do not cancel, if there are polar bonds and the dipoles do not cancel, then yes, each of these molecules is going to be polar. So we would just write that in our answer. So yeah, just put it there, polar, polar. Okay, so we'll look at what the exemplar answer is for this question. So they're both polar, perfect. In CHCl3, there are two types of bond, C carbon to hydrogen and carbon to chlorine, each polar due to the difference in electronegativity between the carbon and hydrogen and carbon and chlorine atoms. These dipoles have different polarities, as hydrogen and carbon have and chlorine have different electronegativities. So despite the tetrahedral arrangement appearing symmetrical, the different sized dipoles do not cancel each other out, and so CHCl3 is polar. So that's really important, is that the dipoles do not cancel each other out, so is polar. If they did cancel each other out, you would say the dipoles do cancel each other out and the molecule is non-polar. So that's like a really good finishing statement that you should always use for these questions. In NH3, the three nitrogen to hydrogen bonds are polar, have a different dipole due to the difference in electronegativity between nitrogen and hydrogen atoms. These equally sized dipoles are arranged in a non-symmetrical trigonal pyramidal shape, resulting in the bond dipoles not, so again, bond dipoles not cancelling each other out, and so NH3 is polar. So that's what this section of the structure and bonding topic comes down to. It's effectively these two questions. So first of all, you need to learn the theory behind it, and then you need to learn how to answer the exam questions. And there will always be an exam question on molecule shape and polarity of molecules. This one was probably the hardest type of question you will get, because even though this is a symmetrical shape, the bond dipoles do not cancel. So thank you very much for watching these videos. Next we will move on to metals and continue on with the structure and bonding topic. So be sure to like and subscribe for more Year 12 chemistry videos. Thanks very much.